Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem. This is the path sum 2. So this is a medium level problem and we'll understand step by step how we can solve this question. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. In the question, we are given the root of a binary tree and an integer target sum. So there's a root and a target sum being given to us. So we need to return all root to leaf paths where the sum of node values is in the path equals to the target sum. So all the paths we need to return from root to leaf, all the paths where the sum of the root values is equals to our target sum. Okay, each path should be returned as a list of node values, not node reference. Okay, so we need to return all the node values as well. That's in each path. So that's what we need to do. Now, what it means, root to leaf path is a path starting from root and ending in the leaf node. They're explaining it, and the leaf node is a node with no children. That's a common understanding we have. So let's understand how we should go ahead and solve this. In this first example, we are given a target sum of 22. Fine, that's the 22 being given to us. Now, how we should go ahead? We should one thing is it should be understandable that once we need to find route to leap path, we should follow a DFS approach. DFS approach means a depth first search approach where we'll find out like each of the paths and then keep on traversing the next node paths. Okay, so this will be our proper approach. Like we should first go ahead from root to the leaf, each of the leaf, then move back to the upper value and then move down to the other leaves. So this will be our approach. As you know, this is what we call left root right. Okay, that is in order traversal. So this should be our approach. So now the question is how we should maintain this. See, one thing, to note each path, we need to keep another list. Okay, so we need to return like a 2D lists. Okay, right? So to keep track of each path, we need to keep a temporary list. So this list will store our all the values we are currently finding. Okay, and once we find that after at reaching the leaf node, if we find that our sum is equals to our leaf, like sum is equals to the target sum, then we should add that to our add this temporary list to our answer list, okay, or the resultant list. And then similarly, like if we have say added 5 4 11 7, okay, and we find that this is equals to our answer list, like this is equal, the sum is equals to our target sum, then we should add this particular list to our resultant answer. And then what we will do, we will remove the last element and add another list. Okay, so once this is done, like add the other part, and then once we will check for the other route to leap path. Okay, so if we find that too is an equals to the target sum, then we will add that to our resultant list, and then keep removing our elements from the bottom. Okay, and then like this is the way we should go ahead with. Now, how we should keep a track of this target sum? Okay, so that's one of the questions that should arise in your mind. Now, look, we can keep a track directly while going deep into the like while going depth in each of the depth. How exactly? If you say the first root node is 5. Okay, so in if we go to its left or to its right, anyways we need to have a value of 5. 5 should be included with us, right? So how should we consider that? So our target sum is 22. Fine, so our target sum 22 minus 4 will be the value that's we should look for in our left, like I'm sorry, 22 minus 5 will be the value we should be looking for on our left, and 22 minus 5 will be the value we'll be looking for in our right as well. Fine, so that's what we need to check. Now, once we do 22 minus 5, that remains us with 17. Now, then we'll check for 17 minus 4. Fine, 17 minus 4. So 17 minus 4 leaves us with 13. So we'll check for 13 minus 11. Fine. That leaves us with 2. 2. So we will check for 2 minus 7. Okay, 2 minus 7. And if this is equals 0, then we found our path. And similarly, on the right hand side, will be also set the 2 minus 2. Okay, if this is equals 0, so we find our path. So that's why we find that 5, 4, 11, and 2 is a path we should look for, not 5, 4, 11, 7. Okay, so this should be our process to just look ahead. Okay, once we are going in each step, just subtract our current root value from our total target sum. In that way, we are not hampering the exact target sum variable for all the values. Why? Because we are sending it as a value, like pass by value, to each of the different function call. Once we are going to its left, that's a different function call, and once we are moving to its right, it's a different function call that's being made. Okay, so that is the approach you should follow over here. Now, how should, like, when will be the time when we should check for this 0? This will be checked, will be done whenever there is a left is null, okay, or root left is null, root right is null. That means it is the leaf node with no children, right? And once we find something like this, we should simply return, like, we should check for this 0. Now, once we find this path, we should add this path to our final answer list, right? And once our answer list is ready, we should we should return that fine path. Okay, so that's pretty simple. That's not highly complicated way. So let me quickly write this code, and then you will be able to understand this much better. Fine, like how this exactly is going on. So let's quickly write this code. If possible, let's see if I can uh, keep this uh, drawing as it is. So in that case, yes, no problem with that drawing. So in that case, it will be pretty easy to go ahead with it. Fine. So let's quickly go write our code. Yeah, you can see like this is a 1 millisecond runtime solution. And if I just say you how this exactly worked, was something like we initially took a result, that's a final resultant array, like resultant list, and then another list that is current. So this is storing over all the current path values. Fine. And then we're calling a function called DSS, and in that we just passed our root, that is the root given to us, then the target sum, then our current, then our result. So all the values we have, we just passed on to it. Now, the first check is if root is null, return. Fine. If anyways our root is null, so there's no point checking further, like nothing going on. Else, what we're doing, we're adding root value to our current. Okay, so we are adding root value to our current. So if I just look carefully, then we'll see that once we root value dot in our current. Okay, so first what we have 5. So first we just added 5. Okay, I'm writing it over here. Then we're checking if root dot left null and root dot right null. Is it so? No, nothing is null. Root dot left is not null. So this check is not happening for 5. Next we move on to the else part. So we again call this DFS function with root dot left. Okay, and another function recursive for call being stored. That is root dot right call is also stored here. So first we just called with root dot left. Fine. So what? So the call happens. This call happens. So root dot left is being called. Fine. Now currently our array has like our current array or the current list have 5 in it. Right. Now we just call root dot left, and what happened? Sum minus root is given. So in our sum, the value we just said sum minus root. So that means 22 minus 5 is being passed on over here. That is 17 is the current sum that is being shown. Now Again, root is not null, so current dot at 5, root dot val, so root dot val over on the left is 4. Fine. So you got 4 over here. Now, is root dot left null or root dot right null? Is both of null? No. So we this condition is not going further. So we are again calling this else part, that is root dot left first. Okay, with sum minus root, that is 17 minus 4 is being called. Like sum was over here, is minus 4. Now we got 11. 11. So is root null? No. Then current dot at 11. We added 11. Fine. Now further we're checking that is any of them is null. None of them is null, so like not left child, not right child is null, so just went ahead with the next part. Now in the else part, what we find, we again need to call with the root dot left, right? With the root dot left, but sum minus root. So sum minus root is 13 minus root, that is 13 minus 11. This is the call over here, that is 2 is currently sum. Okay, so we just call 13 minus 11. Fine. Now again, we just came over here. Is our root null? No, we found 7. Now, so we added current dot at root dot val. We added 7. Fine. This condition of 7, left is null, right is null. Yes, left is null, right is null. We found it, and once we found it, and we find the sum is the sum equals root dot val? No, sum is over here 2. Okay, because 13 minus 11 is being passed, so sum is over here 2. So 2 double equals 7? No, so this condition doesn't valid. Fine. So once this condition isn't getting in, we just went ahead to check the root dot val. Fine. We just went ahead with the root dot left. On root dot left, we find null. So root is null, return. Then we went ahead to root dot right. Root dot right is null. Okay. So we return. And after return, what we find? Current dot remove, current dot size minus 1. So we remove the last element. Okay. We remove the last element. Next, what we are left with, once it's removed, we just return to the previous step. So that is 13 minus 11 over here, value is 11. Okay, now the root is 11. Now we are going to the root to right. This is the recursive call that is stored with it. Okay, because we didn't call this previously, we just went ahead with the root dot left. Now we are going ahead with the root dot right of 11. Now root dot right of 11 is 2. Initially, is it null? No, we just added 2. Fine, we just added 2. Then is it left null? Yes, that is left of 2 is null, left right of 2 is null, and sum equals root of val. Yes, sum equals root of val. So in our resultant array, resultant list, we just add this to our result. Fine, and we then remove the last element. Fine, the last element got removed. Like first we added this to our result, then remove the last element. Fine, and then we returned out of here. Okay, so remove the last element and returned out of here. So that's the way we are going ahead with it. Now once we move back to this 4, we move to his right, it is null. We move back to his 5, we move to his right, that is 8, and then we keep on checking for similar fashion what's the value and how we should do that. So the main story over here is doing this directly, sum minus root dot val. So this is, I think this is the main trick to do this. Else what you need to do, you need to take another variable called sum or some other variable that will store the current, and we will check whether a current sum is equal to a root dot val like target sum or not. Okay, so that kind of checks can be done. So to simplify this, we went ahead with directly subtract. So this is how this question is done, and I think this is not a tough question. This is pretty much easy question, and I hope I can make you understand how you should approach this question. So go ahead and solve this in today's LeetCode problem, and also make sure to comment down if you have any problems facing this. If you are still facing any kind of problem or any doubts you have, so I'll be happy to help you out in the comments as well. And thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.